Okay, today we're doing 1-8 perimeter, circumference, and area. The perimeter, as you know, is the sum of the lengths of all sides of a polygon. The area is the number of square units of a polygon that it encloses. So the perimeter is always around the outside, your fencing. The area is how much grass you have inside your fence. So if we have a square, all your sides are the same length, so your perimeter is going to be 4 times that length, or length plus length plus length plus length gets 4L. Area is going to be length times width, or L times L, so it is L squared. When you have a rectangular shape, you add the 2 lengths, the 2 widths, so your perimeter is always equal to 2 widths plus 2 lengths. Your area is always length times width. Triangle, if you look at my original rectangle here, a triangle is half that amount. So you take, for area, 1/2 base times height. So whatever this line that is dashed, your height is perpendicular to. So in this rectangle, W would be your height, L would be your base of that triangle. To do your perimeter, just add all your sides, A plus B plus C. When you have a circle, we no longer call it perimeter. We call it circumference. Your circumference equals pi times the diameter, or 2 times the radius, which is the same as your diameter, times pi. Area equals pi radius squared. So you take your radius times itself, and then times pi. In most of the problems we're doing, they want pi just left as the symbol pi. If you have your diameter all the way across, so this whole length is my diameter, I have to divide it by 2 to get my radius. All right, so some example problems. When we find the perimeter of a rectangle, that looks a little nicer, that is, actually, this is a square. It's marked. All these 4 sides are congruent, so if they have the same marking in each side, it's congruent. So 3 plus 3 plus 3 plus 3, or 3 times 4, which is perimeter of 12. To find our area, we have to take the sides and multiply them, so it's 3 squared, which is 9. Whatever units you have are going to be squared also, so that would be feet squared. With perimeter, because you're adding them, it would just stay feet. Area is always a square unit. When we have a circle, our radius is 7, so our length, our circumference all the way around, is going to be 2 times pi times 7, so 2 times 7 is 14 pi, and you would leave it in that, in those units, and my unit of measure was meters. So an area, pi radius squared, so 7 squared is 49 pi, and then my units would be meters squared. You don't have to put 3.14 in for pi. They just want you to leave all your numbers in terms of pi. Okay, so then they change it up a little bit and make you graph. So on your XY axis, so again, horizontal is X, vertical is Y, they want to graph each figure, find the perimeter. So we find X is at 0, 2, so I plot that. Y is at 4, -1. Z is at -2, -1. So again, you always do your horizontal first, your X value, and then up or down is your Y. So X, then Y. So I end up connecting all of them, and I have a triangle. And on this triangle, I have this flat side, which I could count, or you know the distance is this value, which was 4, minus the negative 2, so it has a length of 6. So xy is 6, or you count 1, 2, 3, 4, 5, 6. When we want to find any sloped value, we have to use that distance formula because it's on an angle. We can't just count it and find its length. So xy, this was my x value was at 0, my y value was at 4, so 4 minus 0, and then we were at negative 1 minus the 2, or if you just go back to these, 4 minus 0, negative 1 minus 2, might be easier than looking on the graph. So 4 minus 0 is just 4, 4 squared is 16, negative 1 minus 2 is negative 3 squared, which is positive 9, add them together, 16 plus 9 is 25, take the square root, and that length of xy is 5. Then we're going to do the same thing for xz. So if we look at x value of x and the x value of z, we have 0 and negative 2. So I went through 0 minus negative 2, and then 2 minus negative 1, which makes positive 2 for my x's. 2 plus 1 is 3. Come back 2 squared, and 3 squared would be 4 plus 9, square root of 13. So my perimeter is the 6 plus the 5, which is 11, plus the square root of 13. That is my exact measurement. If we put in the decimals, then we would have an approximate measurement, and they want exact. So that's why we left our circle in terms of pi, because they wanted exact measurement, and that's why we don't put square root of 13 in the calculator, because again, they want exact measurements. Okay, so the last two types of problems they're going to be doing are larger area problems. So you don't have your standard rectangle, square, you have a combination of them. So in this large rectangle, they've cut out this area here. So they marked it over here that the height from this point to that one is 5 meters. So sometimes they put it in the drawing. This 4m is from this point to that point horizontally. Vertically from this point to this one is this measure out here. I know from these two vertical sides it is a total of 20 meters. So if I have 8 and 4, which is 12, that leaves this amount being 8 meters also. So you can find some missing sides by what you know. This whole length here between the base and the top is 18. So if we have this height as 5, from here up to the top would be 13 meters. So then we can divide it into sections. We could look vertically and draw a line here so that we find the left rectangle, the center rectangle, and then this right rectangle. I thought about it horizontally, so I divided it here. So I have this little rectangle that is 5 by 8. This rectangle would also be 5 by 8. And then the large rectangle is 13 by 20. My height is 13. My whole width is 20. So 5 times 8 is 40. 13 times 20. 13 times 2 is 26. Times 10 is 260, and then I add those together, but remember I had that extra 40, so we have 260 plus 40 plus 40, 260 plus 40, 340. Again, it was area. Area is always your unit squared. So if you want to divide it vertically, you could divide it here and do those rectangles and add them together. It all works the same. Just don't miss any parts. A lot of times when I'll multiply in the area, I'll write the units that I end up with in my little areas, and this was the 260 for the whole way across, and then add them up so I don't lose anything. So my last example is one that they've pulled information out of. So in other words, find the area of the shaded region. So I just want to find all this outside. So I had a big rectangle and a smaller rectangle, but I don't need that information inside. So basically, you have the large rectangle minus that small one. Because if you take that out, cut it out, all you have left is this outside part that they shaded. So the whole large rectangle was 8 by 12. The small one was 6 by 4. 8 times 12 is 96. Minus 24 gives you 72 square inches. And those are the type of problems you'll be doing in your homework for 1-8.